To understand a p-n junction, we must look at what happens the exact moment two different types of semiconductors meet. On one side, we have n-type silicon, doped with phosphorus to create an abundance of free electrons. On the other, p-type silicon, doped with boron to leave holes, essentially positive spaces where an electron should be. When joined, nature seeks balance. Through diffusion, electrons from the n side rush toward the holes on the p side. At the junction, they recombine and vanish. But this leaves behind a wall of fixed ions, positive on the n side and negative on the p side. This carrier-free zone is the depletion region. These ions create an internal electric field, a barrier potential of about 0.7 volts for silicon that acts like a microscopic standoff, stopping further flow and creating the fundamental one-way valve of electronics.